Hi everyone, today we're going to be talking about an introduction to compound inequalities. So its real-world relevance we can see in many situations. It's natural for the values of interest to have two restrictions. Below are two examples of where we can see that. So the first example says the element mercury is a liquid as long as the temperature is between 37 degrees Fahrenheit and 674 degrees Fahrenheit. So if I just wanted to represent that as an inequality, if I created the variable t to represent the temperature, then as long as the temperature is greater than or equal to negative 37 degrees Fahrenheit and is less than or equal to 674 degrees Fahrenheit, that is the sweet spot for when the mercury is in liquid form. Now notice when I wrote my inequality, more specifically my compound inequality, it is what we can call sometimes a bounded inequality or a three-part inequality. And so the other thing that you'll notice, oftentimes we will put the smaller number on the left-hand side and the larger number on the right-hand side, just like we do in interval notation. So that is how we would write that kind of compound inequality that is bounded or connected. Now, the next example says the Medicare Part D prescription drug plan has a gap in coverage called the donut hole. In 2013, that meant a person's drug costs were covered by Medicare as long as he or she spent less than $2,970 or $4,750 or more. So let me create a variable. I'm going to call it D, which equals drug costs. So those drug costs were covered as long as D was less than $2,970 or D was greater than or equal to $4,750. So this one's slightly different in that we have to separate the inequality with the word or. If you look at this table down here, this is what we call a disconnected type of compound inequality. So notice that here they used S, but I used capital D. That either of these is fine. They used S to represent the amount spent. And then in the top inequality, that was bounded, and it's sometimes called a three-part inequality. And so they use capital T as well. And so that just means that t is greater than or equal to negative 37 and t is less than or equal to 674. Also, if we wanted for both of these, we could write these in interval notation. And so this one would be negative 37 with a parenthesis, comma, 674 with a bracket, since notice this is less than or equal to. Okay. And then the interval notation for the other one, we could say negative infinity to 2,970. And then when we have these two intervals that are not connected, we use this capital, it almost looks like a capital U symbol, and it stands for union. And then we write the next interval, which would be sorry, I'm now just realizing that this up here should be a bracket as well. I was mixing up the two examples. So both of those are less than or equal to, which indicates in this interval that both of those should be brackets. But for this one down here, because it's S is greater than or equal to 4,750, we want to put a bracket there. And then go off to infinity like that. So this symbol here, this capital looking U symbol, remember that is called the union symbol. So take a moment to reread the descriptions above and highlight anything that might not make sense. Write a question off to the side or list something you wonder about the description in the space below before moving on to the next page.